Okay, guys, so what we're doing today is reason, explain, and critique. We're going to be looking at two problems that have similar numbers and thinking about how we would solve them differently using division of fractions. So, really trying to organize it out. We're going to be thinking about our tape diagrams. Do they accurately model the problem? And how do you know? Does your answer make sense based on the problem? And how do you know? And should you revise? So we're just going to be looking at a few problems together. In your class, your teacher may have these separated out for you. You could do them with a partner. You could work together, and or you could just listen to our analysis about it today. All right. So Pablo decides to read one third of a book. Like I said, you need to get this from your teacher or follow along with me here in 5 days. So he's going to read one third of a book over 5 days. He reads the same amount each day. That's how we make it a fraction problem. And how much does he read each day? Okay, so what I want you to do at home or at school or wherever you are is to draw this tape diagram, right? One third of a book in 5 days. So think about what your total is going to be and what you're going to break that tape diagram into. Here's what I did, right? One third of a book in 5 days. And I have my one third of a book. Sorry, I'm not doing very well at covering the other parts, am I? And I'm breaking it into 5 days. And the question is asking me, how much does he read on each day? So I know my answer is looking at one day. So my total is one third of a book, right? Okay, now that would be one third divided by 5 because it's one third of a book broken into 5 days. And 3 times 5 is 15. If I start with a fraction, I end with a fraction when I'm dividing fractions. So my answer is going to be 1/15 is how much of a book he's going to be reading. But let's also look at the whole book, right? I like to expand it out and look at the whole book so we can see here the whole book would be 15/15 of the book. And this is the whole book. So if I'm looking at one third of the book, just like this is like a close up view of this section right here. You see that? So I have um, 1 out of 15 when I'm looking at just one day. Okay, nice. Now let's look at the second question in set one, also talking about Pablo and reading, but now he has 5 books on his reading list and he reads one third of a book every day. How many days will it take him to read all 5 books? Is the question. So a little bit different, right? Now we have to think, what is the total and what am I breaking the tape diagram into? Okay, so those are the two questions you're always going to be asking when you're using tape diagrams. And here you can see our total is 5 books. That's how many books he has to read altogether. And he's reading one third every day. And we put this dot here because we don't know how many thirds are going to be in those 5 books. But our question is how many thirds? How many days? Because each third is a day, right? If you remember from the question. And so what we're doing is we're taking our 5 and we're saying how many thirds are in 5. Now this time we're starting with a whole number and we're ending with a whole number, right? When we divide fractions, start with a whole number, end with a whole number, and how many thirds are in 5 is really what we're asking. And there are 15. So that means it's going to take 15 days. Once again, we like to expand it out and look at the whole, right? So it's still 5 books. So in this case, it's expanding out this way, right? But we're showing every third, and we can see a third a day, right? In 5 books. So I'm sorry, I'm thinking about how 3 thirds would be 1 book, 6 thirds would be 2 books, 9 thirds would be 3 books, 12 thirds would, I'm sorry, 1, 2, 3, 4, and then there's your 5 books, right? If you want to show that 3/3 is going to make one book. So really using your tape diagrams to think about what you're doing. And when you make your own tape diagrams, you're really thinking about, am I modeling it here? Am I showing it here? All right. And let's go to set 2, also sets that your teacher has. Let me just cover up all of the gobbledygook there so we can just focus on the problem. Pause me at any time, work on the problem yourself, come back and do it with me, whatever works for you. Zara competes in a race. She runs 2 miles. It's a little bit like a Z. She runs 2 miles before she pauses for a water break. 2 miles is 1/6 of the race. How many miles is the race? Okay, so she's going to run 2 miles and then pause. And we know that 2 miles is 1/6 of the race. So see what you can draw. Can you make a tape diagram? You can pause me here and then come back, but really challenge yourself to try it out. Okay, so she runs 2 miles and she pauses, and 2 miles is 1/6. So I have my tape diagram broken into 6 parts with 5 lines. And if 2 miles is 1/6, then by the rule of tape diagrams, every block is going to be a 2. And I can just fill those in, and that tells me that the race is going to be 12 miles. All right. I know it can be a little easy when you hear the explanation, but thanks for really trying it out and checking your work. You can also put a number line underneath if that's going to help you to see the sixes. Remember, this is for you to understand to understand tape diagrams and to understand word problems. And word problems are extremely important because when we figure things out in life, we're really doing word problems, right? This could be a problem like you're planning a race. You're going to have water breaks, and how long is going to be the race? Where are going to be the water breaks, right? Thinking critically and figuring these things out. Let's look at letter B on set 2. Zara runs every day for 1/6 miles. I didn't think that seemed very far. She splits her run into 2 equal distances, so she breaks her 1/6 into 2 parts, so she can pause for a water break. How many miles does she pause? After how many miles does she pause for a water break? So they're basically asking us, where is that water break, right? Okay, once again, pause and do the work, and then come back, and let's look at the answer. So I have 1/6 of a mile, right? 1/6 of a mile, I'm going to break it into 2 parts. So basically, I'm asking, what is half of 1/6? 1/6 divided by 2. And start with a fraction, end with a fraction. It's going to be 12. So 1/12, because 6 times 2 is 12, right? So she runs 1/12 of a mile when she stops for water break. Now, if we want to look at the whole mile, we can see that 1/6, if I break every sixth into 2 parts, then each part will be a 12th, and this is a blow up of this little piece right here, right? Like if I was just gonna zoom in on it. Okay, I hope that's really helping you. Make sure your answers make sense. Sometimes my students will say something like 12 for this kind of a question. After how many miles does she pause for water break? 12 miles. Well, she's only running 1/6, right? So we got to really look back. That's why we write word answers, so that we can really look back and make sure that it's making sense as we are answering the question. All right. Thanks for watching. You guys are awesome. Do great work. Aloha.